Hello students, today we're going to talk about inductive reasoning and trying to determine what counterexamples are. Please don't forget to take notes as you go and complete the survey that follows this video. So what is inductive reasoning? We're going to look at different types of reasoning in this unit since we're going to be doing proofs, so we have to kind of think a little bit logically. The first one that we're going to be looking at is inductive reasoning, and what that is probably what you've done in the past, which is we look at patterns and try to come up with maybe the next couple terms or looking a little bit farther ahead. So inductive reasoning is reasoning based on patterns that you observe. So let's look at a couple of examples. So let's first start looking at a number pattern. What you look for is there something being multiplied? Is there something being added or subtracted? Things like that. So our first example, 3, 9, 27, 81, I'm going to take a look at those numbers and see what I can come up with. So if I look at addition, the first one here, we're adding 6, but that doesn't continue into the next one. So then we look at multiplying. Well, to go from 3 to 9, we multiply by 3, and that pattern continues on. So our pattern here is each term is 3 times the previous term. So I want to know what the next 2 terms are. I would take 81 and multiply it by 3 to get 243, and then take that number and multiply it by 729. Our next example is more of a visual example, or visual pattern. So taking a look, everything has a circle in it, so inside is what we're worried about. The first one has a triangle in it, so there's 3 sides. The next one is a quadrilateral, or 4 sides. And the one of that is a pentagon, or 5 sides. So what I'm noticing is as I'm increasing in the term, I'm increasing the number of sides by 1. So my pattern is each circle contains a polygon that has 1 more side than the preceding polygon. So what that means is the next 2 have to have 6 and 7 sides. So this is what they would look like. The first one would have the hexagon, and the second one they would have the heptagon inside. Now, sometimes we have to find terms that are not the immediate next term, so it's a little bit more difficult. So what we will do is make some kind of conjecture, which is a conclusion that we get by using inductive reasoning. So what I mean by that is, let's look at this example. I want to make a conjecture about the number of regions 20 diameters might form. So let's take a look at what would happen if we had 1 diameter. So if I put 1 diameter in there, it's going to create 2 different regions. So let's see what happens now when I increase that from 1 diameter to 2 diameters. And I'm noticing here now is that I have myself 4 different regions. So 1 diameter causes 2, and 2 causes 4. So I'm starting to come up with an idea of what might be happening as I increase diameters. So let's go ahead and do it one more time. So now I have 3 diameters, and what I'm noticing is that there are 6 regions formed. So my pattern I'm noticing is that however many diameters I have, if I double it, I'm actually getting how many regions I'm getting. So that's what my conjecture is, that the number of regions is equal to the number of diameters times 2. So it's just essentially stating what the pattern is. So in this one here, if I'm talking about 20 diameters, then I'm going to expect it to be 20 times 2, or 40 regions. But not everything that we state is true, so you have to keep that in mind. All you need to do now is come up with an example that would make that, that would show that conjecture is actually false. And that's called a counterexample. And that's an example that shows a conjecture is incorrect. And when you need to just disprove something, you only need to have one case in which it's false. So when you're proving something, you have to show it for every case. When you're trying to disprove, you just need one single counterexample. So again, that's what I just said. You only need one example to disprove a conjecture, but need to show every case to prove it. So let's look at a couple of examples of what we would do for counterexamples. So for the first one, if the name of the month starts with a J, it is a summer month. While that is true for June and July, that's not the only months that start with a J. We also have January, and that is mostly, or is all, in the winter. Let's look now at more of a mathy thing. You can connect any 3 points to form a triangle. So sure, we can create 3 non-collinear points and it would be a triangle, but as soon as we take those 3 points and we put them in a straight line, they're no longer forming a triangle, okay, because now that they're collinear. And lastly here, when you multiply a number by 2, the product is greater than the original number. Well, what we're forgetting are things like 0 or negative numbers. So I did a counterexample using a negative number. -4 times 2 is -8, but again, that's not the only case that could happen. If you have any questions, either ask them in the survey or bring them to class tomorrow. Please make sure you complete the survey that follows. I'll see you tomorrow.